Okay, welcome back to the theory of probability. So what we are going to do today, and maybe we quickly recall what we did last time. So we talked about discrete random variables, the random variables that takes discrete values. We talked in detail about it. We talked about what we mean by the PDF, the probability mass function or density function of such kind of random variables. We talked about CDF, how to compute the cumulative distribution function of such random variables. We talked about expectation of x and the variance of x actually. So we talked about this entire theory and how it is useful and several examples of it actually. So what we are going to do today, we will take some of the situations from the real world and we will try to model them through some specific kind of the probability distributions actually. So in other words, what we are going to do, we are going to talk about today some of very famous, some important probability distributions actually, some important probability distributions. Okay, so this is what we would like to do today. Okay, so we will take a particular scenario and identify some random variables in it. We will try to talk about the distributions of those random variables and compute their expectations and variances, and then apply those specific distributions to compute some of very interesting kind of the probabilities actually. So let's start with a very simple example. So consider a situation or an experiment in which there are only two possible outcomes actually. So consider a trial or an experiment in which there are two kind of only two possible outcomes actually. So such kind of situations can model what? Okay, they can model say a coin flip. In other words, you flip a coin. Okay, so there are only two kind of possible outcomes actually. You for example take an exam. So in that exam there are two possibilities, pass or fail. Okay, for example gender of a new baby born. Okay, so let's assume that only there are two genders, then there are only two genders, or any kind of situation you can model it, or any kind of situations in which you do a random experiment and there are only two possible outcomes actually. So in general, in other words, you talk about a random situation in which you have only two possible outcomes, either success or failure actually. Success or failure. Okay, success or failure. So this is really, so you can put all of this in a single box, or you can call all these or such kind of all experiments as the Bernoulli experiment actually. Bernoulli experiment. Okay. So now, what do we mean by a Bernoulli experiment? So it's a kind of a random experiment in which there are only two possible outcomes actually. And you call one of the outcome as a success and you call the other outcome as failure actually. For example, in coin flip I can say by head I mean success, and by tail I mean failure actually. Or in exam, I would say that by passing, I mean success, or by failing, I mean failure actually. Or gender, by girl, say for example, I can say having a success, or by boy, I'm having a failure, and so on and so forth. So I'm gonna say that a random variable is a Bernoulli random variable, okay, if it takes only two values. In other words, you take such kind of an experiment in which there are two possible outcomes and you do it once. So it's like flipping a coin once, or taking one exam, or considering the gender of a one baby, or doing something one in which you have success or failure actually. So a Bernoulli random variable is a random variable which take, for example, only two values. So let's call those values as 0 and 1. Okay, and let's interpret 0 as, for example, failure. You can do other way around. And by success, let's interpret the value 1 as the success. Okay, and let's assume that success occurs with the probability P, and failure occurs with the probability, say 1 minus P, obviously, and obviously P is a number between 0 and 1. Okay, so what would be, so that's a random variable, and this is really the probability distribution of a Bernoulli random variable. For example, you can write it in a more concrete form for the PDF of, say, Bernoulli trial at, say, 1 is P, and its value at 0 is 1 minus P. So this is really the probability mass function for the Bernoulli random variable. You can ask more interesting questions. You can ask, what would be the expectation of I think we should do this strict so that you can have two outcomes actually. So we can't have equality with 0 and 1. Anyway, so what would be an expectation of this random variable? So it's easy, you have calculated it previously, so it's going to be the expectation of x. So if you are interested in computing the expectation of any kind of random variable, just check that what values it takes, and just multiply those values with the corresponding probabilities and get it. So for example, 0 multiplied by 1 minus P plus 1 multiplied by P. So the expectation of a Bernoulli random variable is really the P. Okay, and what would be the expectation of x squared? In other words, what would be the second moment of it? So it's going to be 0 squared multiplied by 1 minus P. So I assume that you have in your mind our previous expectation, that how to compute the expectation of a function of a random variable, 1 squared multiplied by P. So the expectation of x squared is going to be again, what do you call, P. And the expectation, and what would be the variance of a Bernoulli random variable? The variance of the Bernoulli random variable is going to be the expectation of x squared minus expectation of x whole square. So if you substitute the value, you're going to get P minus P squared, in other words, P times 1 minus P. In other words, it's simply the product of the probabilities of success or the failure actually. So that's really a complete description of the Bernoulli random variable. And what Bernoulli random variable can model? So it can model anything in which you do an experiment once, and in that experiment there are two possible outcomes, either failure or success actually. So every single thing that can be modeled, every single random experiment that has two possible outcomes, okay, is going to be a Bernoulli experiment actually. Okay, so this is really about the Bernoulli experiment. So you can think of many different kind of such situations. So these are just some examples, which can have more examples जिनमें you can model it through the Bernoulli random variable actually. Okay, you can have, for example, a bet, and you can either lose a bet or win a bet, whatever. Okay. So the next distribution is really connected with the Bernoulli distribution. So here we are doing a Bernoulli experiment once. But imagine now you say that, okay, let's do the Bernoulli experiments or the Bernoulli trials, but for a fixed number of times. In other words, instead of looking at say taking one exam, you are taking 5 exams actually, and each of the exam there are two possibilities that either you fail exam or pass exam actually. So instead of looking at one coin flip, you look at the 10 coin flips actually, and each coin flip there is so there are two possibilities, head or tail, or win or lose. Or instead of looking at, for example, one baby, the gender of one baby, you look at the 7, or maybe 100, babies actually. Okay. So in other words, extending this. So what we were doing previously about the Bernoulli experiment, that you are doing the experiment once. Now you do the experiment a fixed number of times actually. Say you do the Bernoulli experiment as performing Bernoulli experiments n times actually, where n is a fixed number. Okay, and there is a simple assumption that all of these experiments are independent of each other actually. So you are performing Bernoulli experiment, but one Bernoulli experiment, so in other words one coin flip is independent of another coin flip actually, or one result of the one exam is independent of the result of another exam actually. Okay, so these Bernoulli experiments are, I can also call them trials. So these trials, okay, and trials are independent actually. They are independent. Now, and obviously, since each experiment is a Bernoulli experiment, out of these an experiment, so in each experiment or trial there are only two possibilities actually. There are only two possibilities. So what kind of things it can model? So it can model, as I said, it can model anything in which there are two outcomes, but you do that thing or experiment for a fixed number of time. For example, flipping a coin, say 10 times, or taking, for example, 5 exams, okay, or attendance, for example, of a class of, say for example, 20 students. So you know, so this is also going to be, you know, one of such situation actually. Okay, because each student in the class, the experiment of taking attendance is going to, so in an experiment of taking an attendance, you're going to do what you call the trials actually. So in other words, you're going to, for example, take a name, so that student is either present in the class or not present in the class actually. Okay, so all such things and anything that you can imagine in which you have experiment with the two outcomes and you perform it for two kind of n number of times. So you're going to call that as this experiment actually, and we have a name for such experiment. Okay, so all these can be put in a simple experiment which is called the binomial experiment actually. Okay, binomial experiment. So what is a binomial experiment? So binomial experiment means doing the Bernoulli trials for the fixed number of times actually. Okay, so this is what the binomial experiment is. And from the binomial experiment, we can have the notion of what you call the binomial random variable. By the way, in this, you can't have a binomial experiment cannot model the rolling the dice actually. Why? Because in each of the rolling, there are 6 possible outcomes actually. So in other words, if you want to do this, you need to generalize this actually. Okay, so we'll talk a little bit about it later actually. Okay, so it can only perform model the trials where there are only 2 possible outcomes actually. Binomial random variable. So what is a binomial random variable? So imagine you do a Bernoulli experiment and X represents the number of say successes, whatever successes you associate with, head or tail or boy or girl or passing or failing exam, presence or attendance, whatever, presence or absence. So number of say successes, you can also associate it with the number of failures actually. Okay, number of successes. Then how many successes you can have in an experiment in which you do the Bernoulli experiment n times or Bernoulli trial n times actually. So you can have the situation that you don't get. So in other words, you flip the coin 10 times and how many times you're going to get, for example, head actually. So you can have no head, you can have a worse situation in which you are, you know, you always have a tail, or you can have a 1 head or 2 head and so on and so forth. So if you are doing a binomial experiment, the random variable can take what number of n times, what number of values. So it can take 0, which means that there is no success, you haven't got any success. So it can take value 1, that means that you have 1 success and rest are the failures actually. So rest are the failures. So 2, 3 and so on and so forth, and let's call them n. Okay. So these are the values that a binomial random variable is going to take. For example, in this example, the binomial random variable is going to take 0, 1 and 2. For example, if you associate your success with head, so it's going to take 0, 1 and up to 10 actually. So in this, if you associate your success with passing an exam, then the random variable that kind of represents the number of passed subjects could be 1, 0, 1, 2 or all 5 actually, and so on and so forth. Okay, so that's a binomial random variable. So the next question that we should do, so we'll do some examples of it as well, that how it models different kind of situations. The next thing is obviously that we should ask is that is that, okay, so if these are the values that this random variable takes, then what is the probability distribution of this function actually? So in other words, if I want to compute, say, fx of x, where x could be 0, 1, 2, and up to n, then what would be this fx of x? In other words, I'm interested in what is the probability that your number of successes are x actually. So this is all that we like to state. Exactly x. So one thing is obvious, okay, so we have done this kind of situation before actually, that you're going to say that, okay, if you have x successes and all of these successes are independent of each other and all of these trials are independent of each other, then the probability of a success in a trial is p, then you're going to have the p raised to x as, so it's like a p multiplied by p multiplied by p x times, so you're going to have the, so this is the probability of the x successes actually. So when you have x successes out of n, that means that the rest are the failures actually. So what would be the probability of having rest failures actually? Okay, so you're going to say that it's going to be 1 minus p raised to n minus x actually. Okay, and obviously if you are having x successes out of n places, so in other words, for example, you have 5 exams and you are talking about passing 2 exams out of 5, then okay, so you're going to have p raised to 2 and 1 minus p raised to 5 minus 2 is 3. But you have to also take care another thing into your consideration, and that thing is that which exams you have passed actually. Maybe you passed these 2 exams, maybe you passed these 2 exams, maybe you passed these 2 exams, or these 2 exams, or first and the last exams. So you also have to consider all these possibilities into your PDF as well. So, okay. So in other words, if you are having x successes out of n, then these x successes can be first x successes, last x successes, or maybe some in between. So in how many ways you can have x successes out of n? So we know that we can have x successes out of n and n choose x manner actually. Okay. So this is really the PDF of the binomial distribution is actually. Okay. Where p is a number between 0 and 1. Okay, so it's a probability of having a success in a trial act. So this is the PDF of the random variable. Let's try to answer some of the questions based on it. So for example, so here's an example from Ross, which is 6a from chapter 4. So this is an example 6a from chapter 4. An example goes like this. Imagine you flip the 5 fair points actually. Okay, so they are fair points. And if the outcomes are assumed to be independent, in other words, all 5 points, their outcomes does not influence each other, ठीक है, एक दूसरे पर असर नहीं डालते वो, find their probability mass function actually, आप उनका probability mass function निकाल कर दिखाएं. तो अगर आपको ये समझ आया है, if you have understood it, you can write it very easily actually. Now, so there are 5 fair coins are flipped actually. So this fair is important, okay, because this fair tells you that these 2 probabilities, okay, the probability of having a head and having a tail is equal to each other actually, okay. So the both are 1/2. So there are 5 fair coins flipped, okay, And so what we have to do, we have to find the PDF or PMF of number of probability distribution function of number of heads that appear. Okay. So this is what that we would like to have. So how can we answer this question? How can we answer this situation? So first of all, you will set up a random variable. So let x represent number of heads out of 5 flip coin. Okay, 5 flip coins. And so x can take what value? So it can take 0, in other words, no head occurs, 1 or 2 or up to 5 actually, so it can take 5 outcomes. So what values this can take? So in other words, if I say that fx is the PDF of the probability distribution function of the random variable x, then fx of say for example 0 would be what? So fx of 0 is going to be simply so what would be the interpretation of 0? So in other words, number of heads, so no head occurs. So all 5 are what do you say, tells actually. So if all 5s are tells, so you're going to say you have 1 over 2 raised to 5 as the fx of 0 actually, because all 5s are tells. What would be fx of 1? In other words, what is the probability that x is 1? So you get 1 head actually. So you're going to say you have 1/2 raised to 1. So this is the probability of having 1 head times, because you know all trials are independent, so it's going to be 1/2 raised to 4. 1/2 raised to 4. And so this is the probabilities, the product of the probabilities of having 4 heads. But as I said previously, that you also have to put in your consideration this, that okay, so you have 1 head, but which coin or what on which flip of the coin you get head. So maybe you get head the first what do you call flip, or on second flip, or third flip, or 5 flip. So you're going to say out of 5 places, at 1 place you get flip actually, you get head. So this is going to be really the PDF of it actually. And you can easily generalize this, and you can say that okay, what would be the fx of x? So it's going to be 5 choose x, okay, where x can be 0, 1, 2, 3, 4, 5, anything. And so in other words, x times, out of 5 places, on x places you get, what do you call, heads. And this is the probability of getting x heads, and this is the probability multiplied by probability of getting the 5 minus x tells actually. So if you simplify, so you're going to get 5 choose x times 1 over 2 raised to 5. So this is really the PDF of this kind of situation actually. Okay. So that's one example of. So let's talk about another example of a binomial random variable. Okay. As I said, binomial random variable or binomial experiment is an experiment in which you do the Bernoulli experiment, but for a fixed number